This is Kumaris from Department of Mechatronics Engineering. This presentation is about on theories of failure in machine design. First of all, in case of material when subjected to a simple state of stress like tension or compression, the failure occurs when the stress in the materials reaches the elastic limit. In case material subject to complex stress, the stage of failure is determined either to practically or theoretically. Non-applicability of any one theory to all states of stress and to all materials has resulted in propagation of different theories relating to the complex stress to the elastic limit in simple tension or compression. Since the complex stress system can be simplified into three principal stresses, the problem reduced to two, linking the three principal stress to the stress at elastic limit in case of simple stress. The common most theories are maximum principal stress theory, maximum principal strain theory, maximum shear stress theory, maximum strain energy theory, and maximum shear strain energy theory. The first one is the maximum principal theory or maximum normal stress theory. In this theory states that the failure will occur when the maximum principal stress in the complex system reaches the value of maximum stress at the elastic limit. It may be simple tension or simple compressions. The below equations will show the sigma 1 equal to sigma 8. That means principal stress is equal to the maximum yield stress for in simple tension. Then modulus sigma 3 equal to sigma yc in simple compressions. Modulus of sigma 3 equal to sigma yc. For the design, the maximum principal stress should not exceed the working stress for the materials when sigma 1 equal to less than or equal to sigma. Working stress sigma equal to sigma y by f. Then f is factor of safety. This theory is valid only for the brittle materials such as cast irons. And maximum principal stress theory is valid for thin ball tubes. This theory is contracted in the following cases: when the failure in simple tension caused sliding at 45 degree with the axis of the specimens, thereby the failure occurred due to maximum shear stress and not due to direct tensile stress. Then the material which is weak in simple compressions can sustain large hydrostatic pressure in excess of the elastic limit in simple compression. Next one is the maximum principal strain theory. This was proposed by Saint-Venant, and it states that the failure of the materials occurs when the major principal tensile strain reaches the strain at the elastic limit in the simple tensions, or when the minor principal strain, that is maximum principal compressive strains, reaches the strain at elastic limit in simple compression, and is more appropriate for ductile materials, brittle materials, and metal under hydrostatic pressure, and it does not fit well with the experimental results. These are the equations which for the principal strain theory in the direction of principal stress. According to the maximum principal strain, the condition to cause the failure are shown in the below equations. To prevent failure, the equations which are used in this, and the point of failure, we use the below equations. For the design purpose, we below the equations which shown in this presentation, where sigma t and sigma are the shape stresses. The next one is the maximum shear stress theory. This theory also called as column Gustard-Treschow theory, and it says that the material will fail when the maximum shear stress in the complex system reaches the value of the maximum shear stress in the simple tension at the elastic limit. The below equations which shows the maximum shear stress equations and the conditions for the theory of failure. And this theory gives the good correlations with the results of experiments on ductile materials, and it gives satisfactory results for the ductile material, particularly in case of shafts, and it does not give the accurate results for the state of stress for the pure shear, and it is not applicable in the case where the state of stress consists of the triaxial tensile stress for the nearly equal magnitude. And the fourth one is the maximum strain energy theory, and it was proposed by Beltrán y Haig, and it states that the failure of the material occurs when the total strain energy in the material reaches the total strain energy of the materials in the elastic limit in simple tension. In 3D stress system, the strain energy per unit volume is given by the below equations. At the point of failure, the given equations shown in the below. In 2D stress system, stress is equal to 0. The above equations reduced to sigma 1 square plus sigma 3 square minus 2 mu sigma 1 sigma 3 equal to sigma 2 square. For the design, we use the below equations, and it is applicable for ductile material, particularly in case of pressure level, and is not applicable to materials for which yield stress is different from the yield stress in tension is different from the yield stress in compression, and it does not give the results exactly equal to the experimental results even for ductile materials. If the body is subjected to highest hydrostatic pressure, equal compressive stress on all the three phases, then the basis of the strain energy theory, the maximum compressive stress will be sigma equal to sigma y by square root of 3 into 1 minus mu. That yield stress of the material equal to denoted as sigma y, and strain energy stored in the given equations is u equal to 1 by 2 sigma 1 e1 plus 1 by 2 sigma 2 e2 plus 1 by 2 sigma 3 e3. All the strain stresses are equal in this state. All the strain energies are equal. The equations are shown below are the results. The fifth one is the maximum shear strain energy theory or distortion energy theory. It was proposed by von Mises-Schanke, and it states that the elastic failure occurs when the strain energy per unit volume in the stress material reaches the value equal to the shear and strain energy per unit volume at the elastic limit point in tension, and theory gives the best results for the ductile material, particularly in case of pure shear or maximum stress in compression is equal to maximum yield stress in tension. The strain energy per unit volume to the principal stresses sigma 1 and sigma 2 and sigma 3 is given below. For the simple tension at the elastic limit point, the sigma 1 equal to sigma 80 and sigma 2 equal to sigma 3 equal to 0. The shear stress strain energy per unit volume is given by the below equations. In the equating the two strain energies, we get the equations like this, and in 2D stress systems, sigma 2 equal to 0. The above equation reduced to 2 like the below equations. Some of the design conditions for various failure theory. This table clearly shows about what are the conditions we can do follow in the failure theory. For the first one, maximum principal stress theory, it was proposed by the Rankine, and the conditions for design is sigma 1 less than or equal to sigma. And the maximum principal strain theory, it was proposed by Saint Venance. The condition on design is 1 by e into sigma 1 minus mu sigma 2 less than or equal to sigma y by e. The third one is the maximum shear stress theory. It was proposed by Coulomb, Guest, or Tosca. The condition on design is sigma 1 minus sigma 2 divided by 2 less than or equal to sigma y by 2. The maximum strain energy theory, it was proposed by the Beltrami Haig. The condition for design equations is given as sigma 1 square plus sigma 2 square minus 2 mu sigma 1 sigma 2 less than or equal to sigma square. And the distortion energy theories were proposed by the Haber-Hanke or von Mises. And the condition for design equation is sigma 1 square plus sigma 2 square minus sigma 1 into sigma 2 less than or equal to sigma square. When one of the principal stress at the point is large in comparison to the other, all the failure theories gives nearly the same results. When a member is subject to uniaxial tension, all the failure theories gives the same results. Now we can see some gate questions and their solutions. In this problem, a small element in the critical section of the component is in a biaxial state of stress, which with the two principal stress being 360 megapascal and 440 megapascal. The maximum work stress according to the distortion energy theories. The options given are the 4 options given. How to solve this equation means we can take another major and minor principal stress value, and we used that The conditions for the system, condition for design equations, we can substitute. At last we get the theories of discharge energy theory. Solution is 314.3 Newton per mm square. The equations shown in these are the conditions for the distortion energy theory. So we can already know the major principal stress or maximum principal stress and minor principal stress. Substitute these values in these below equations and we get the failure value will be 314.3 Newton per mm square. Thanks for watching these presentations.